All right. Number 2, we want to consider the following relation. So we have an oval on a coordinate grid, and we want to determine the domain and range. Okay. So since this is a connected line, we're getting a bunch of points. So, for example, if we start at 0 and I go over, we don't know what the first number after 0 is. Okay, so if we're thinking about whole numbers, we can say it's 1. Okay, that's definitely true. But as far as decimals, we could say 0.1, but if you divide that in half, it's 0.05. And you can just literally continually divide that number in half infinite number of times and never really get to 0. We'll get to numbers that we can't really measure with, something visual. As far as money is concerned, let's say if this was like $1, I can divide it into 1/100th at the most. That would be a penny, but we don't have anything smaller than a penny to measure, and so we could actually have 1/1000 here. So we're getting a lot of numbers just between 0 and 1. We cannot list them all, so we will use a different notation, which they say interval notation. When it's a scatter plot, we will list them, but as far as a connected line graph, we cannot. So in order to do domain and range, you are going to have to go from least to greatest every time. So domain, least to greatest. And I normally, it depends on what you have. So the fact that we actually reach our endpoints means we're going to have brackets. Okay, so we're going to have both of these in brackets. So how far to the left? What's the farthest to the left we go? This is 0, -1, -2. So this line, our graph does not go past -2. So that is our lower endpoint in the domain, -2. Then going from to the right, how far do we go? 0, 1, 2, 3. This line is 4, so our graph does not go past 4. It does touch it, so we do reach 4. So our domain goes from -2 to +4, least to greatest. We're going to do the same thing with the range. So range, we're going to go least to greatest, so that means lowest, bottom to top. So again, we're counting how far down do we go? -1, -2. Looks like we reached -3. So that's the furthest down that this graph goes, nothing past -3. And again, it's going to be in bracket because we actually do reach that point. And then how high up? Starting at 0, we go up just 1 unit. So the highest point is 1. And so this is how you'll do domain and range when you have a graph. You're looking left and right for domain, and then you're looking bottom to top for range. Sort of a little acronym that may help you to remember this is I think a high school teacher used this, that think about this as we have 2 math kids. We have Dixie and Roydy, R-O-Y-D. Dixie will be the older sister. Roydy will be the younger brother. If you've ever had a younger sibling, you know anything the older one does, the younger one wants to do. And so let's just say that there was a school dance and Roydy wanted to go. Since he's younger, he needs supervision. So he depends on his older sister. And so I'll kind of put this in context. This is the dependent variable. This is independent. And all of these letters just represent the different names that we give for X and Y. So D is for domain. R is for range. I is for input. O is for output. X and Y are the variables that these words correspond to. And then I is for independent. And then D is for dependent. Okay, so these are just some acronyms that might help you. They all go in alphabetical order except for the last one. Okay, so D comes before R in the alphabet. I comes before O. X comes before Y. Independent, dependent are backwards because dependent will come before independent. But if you have that, that will help you whenever you're reading word scenarios and they're asking for input versus output, dependent, independent. This is just different names for X and Y. So domain is the X. We're going to be doing square bracket -2, comma 24, and then on the range we're going to be doing square bracket -3, comma 1.